giants concept. So we are in giants. So let's briefly explain about giants. Why giants? So most of them knows why giants, right? Why giants? Don't say joining. So to retrieve data from more than one table. More than one table. To retrieve data from more than one table, we use giants, right? To retrieve data from more than one table, we use giants. So if you go RDBMS concept, in RDBMS one special concept called normalization. Normalization. So I think this word we heard from our academics, right? Normalization. So in normalization we saw normal form 1, right? Normal form 1, form 2, form 3, boys card normal form, right? Boys card normal form. Like this we have multiple normal forms, right? There are multiple normal forms. What is the main purpose of normal forms? To generic word to eliminate duplicates, right? To eliminate duplicate data. To eliminate duplicate data. How we eliminate duplicate data? Example, let's take employee details is one table. So we are storing 1 comma AA comma Srinivas comma department number 11 comma department location is Hyderabad comma uh, department location is Hyderabad and department name, department name is testing or development, dev department Hyderabad. So this is the details. So around 100 developers are there. 100 developers. Next 101 comma XYZ department number 12, department number 12. So let's remove this one. Department number 12 testing, location is Hyderabad. So around 50 testers are there. 50 testers. 50 testers. In all records we see a dev Hyderabad. Dev Hyderabad. 100 times we see duplicate data, right? 50 times we see testing and Hyderabad, right? So Hyderabad we are seeing 150 times. 150 times we are seeing Hyderabad, right? 50 times we are seeing testing. 100 times we are seeing dev. Means duplicate data, right? So to avoid this one, this normal forms says divide your data into multiple tables. Split your data into multiple tables so that we can avoid duplicate data. Then what we are going to do, EMP 101 comma Srinivas comma 11. Like this we write 100 records, 100 dev. Next 101 comma XYZ comma 12. 12 I write 50 records, 50 testers. Next, EMP details. Sorry, uh, department DEPT we create one more. So 11 comma dev comma Hyderabad, 12 comma testing tester or testing tester comma Hyderabad. So we created only two records. We create relation between these two tables. We create relation between employee table and this table. So this record is pointed, common column is department number in both columns. Both tables we create common column. So whenever you want to retrieve data from, we want EMP details, then we read, we compare both tables common column. So 11 department, we compare 11 and we display 1 Srinivas, 11 Dev Hyderabad. To retrieve data from two tables, we are using joins here. We use joins. In the joins, we use common column of both the tables and we compare. If common column values are matched, we retrieve records. Okay, joins are used for retrieving data from more than one table by using common column. By using by splitting tables, we reduce duplicate data. So normal forms says that normal forms main purpose is to eliminate duplicate data. For that one, we have multiple normal forms. Normal form 1, 2, 3, by squad. There are multiple normal forms. Each normal forms contain different rules. Based on that rules, we split data into our multiple tables. Okay, if you apply normal form 1, we follow some rules. If you apply normal form 2, we follow some rules. If you apply biased normal form, we apply some rules. So biased form, normal form is popular normal form. So based on biased normal form, we split the table into multiple tables. To retrieve data from multiple tables, we have to use joins. There is no other alternatives. First, we are learning advantage of joins. We are to retrieve data from multiple tables, we are using joins. First main purpose is to retrieve data from multiple tables. Okay, to retrieve data from multiple tables, we use joins. If you want to apply joins, two tables must have common column. Note that point. If you want to apply joins, two tables must have common columns. So there are some joins we can use without common column also. In that case, we get uh, duplicate data, duplicate records. Why why RDBMS why RDBMS applies normal forms? Why RGBMS applies normalization? First reason, to eliminate duplicates. First reason, to eliminate, eliminate duplicates. Second reason, to save memory. To save memory. To save memory. Because of duplicates, earlier this Dev and Hyderabad repeated 100 times, right? Testing, Hyderabad repeated 50 times. So instead of that, we are saving only one time, right? Here we use in department, we created only one time. Assume this this one we allocated 20 varchar of 20, varchar of 20. So 100 into 20, 100 into 20 plus 20. So 100 into 40, 400. 100 into 50 into 40, 200. Total 600 memory locations we saved, right? What if lakhs of records are stored in RDBMS tables? Cores of records are inserted in RDBMS table. In that case, we saved lot of memory, right? So because of normalization, not only eliminating duplicates, we saved a lot of memory. So memory is important. RDBMS hardware is not normal hardware. RDBMS uses server hardware. Server hardware is very costly because RDBMS servers must run 24 by 7. If it downs at least 1 hour, we lost customer clients lost lot of business. Assume Amazon. If Amazon downs in 1 hour, what will happen? Course of business is lost, right? Course of business. In India only 100, our Indian people only purchasing lot of products from Amazon, right? So nowadays no one using RDBMS, everyone using big data only. Assume big data is down in 1 hour, then they lost course of business. So they want RDBMS or big data must be run 24 by 7. 24 by 7. That's why they spend money for hardware. They cannot think. This is one time investment, right? So if you are using server hardware, so memory is important, right? Memory is important. To save memory, we apply normalization. So why the people RDBMS people apply normalization means because hardware is costly. In to reduce processing, we'll discuss later. So main purpose is to save memory to avoid duplicates. Okay. Yep. So joins we have inner join and outer join. Inner join also called equijoin. So inner joins we use common column. Inner joins we use common column. Inner joins we use common column. Only matched records, only match rows with inner join condition. We have different joins, inner join and outer join. Inner join and outer join. So inner join we apply on matched records. It means both tables must contain common column. Both tables must contain common column. So we have already employee table, right? We have already employee table. So if you want to use Linux command, we have to use exclamatory mark clear. Linux command will work on Hive environment. Yep. Yep. For line Hive, I want to display ls. I want to display my data, not cat. File name emp to display local file data. So for every Linux command, we have to use this exclamatory mark. Otherwise, every statement is going to convert MapReduce. So we have already a table EMP. Select star from EMP. So employee number, employee name, salary, gender, department number. Let's take file, DEPT file, cat greater than DEPT. So I'm taking department number 11, dev department, and location is Hyderabad. Department number 12, so testing department, and Bangalore. Next, department number 13, HR, Chennai. Next, department number 14, uh, management, Mumbai. Next, department number 15, accounting, accounting, and we are using uh, Delhi. Just use some departments and locations. So this is the file. From Hive environment, we can display what? By using NAT, cat. File is presented under batch file slash DEPT. Okay. Create a table. Create a table DEPT. Create table DEPT. Department table. Columns are first one department number, int comma, department name, string, comma, department location, string, row format delimited fields, row format delimited fields terminated by comma. What happened? Terminated spelling may be. So create table name, columns list. Let's see terminated, right? Terminated by comma. Correct, right? So DESC, EMP, DESC, DEPT. DESC means describing table structure. Describe table structure. So table contain, these are the columns, EMP table, and department table contain, these are the three columns. In these two tables, common column is department number. So if you want to apply inner join, we use common column. So first, joins purpose is to retrieve data from more than one table. So inner join means we retrieve data from more than one table, data from one table, more than one table based on common column, based on common column. So outer join, we can retrieve both table data only, but matched records and non-matched records, matched rows and non-matched rows. So what are non-matched rows? We'll see. Again, outer join is divided into two parts, three parts: left outer join, right outer join, full outer join. So based on left outer and right outer, full outer, these non-matched records are dependent on left outer, right outer. Full outer is a combination of left outer plus right outer. It is equivalent to left outer plus right outer. Let's first start inner join discussion. So inner join we have two tables, right? Let me write this one. So outer joins we have mainly two, left outer join, right outer join. So people little confuse left outer and right outer, but there is no difficult. Why people confuse? So it's very simple. Most of the people confuse. Okay. Yep. So once our discussion is completed, you can easily remember left outer and right outer. Here for our it won't require. For Hive it won't require. But RDBMS without creating relation between two tables we cannot retrieve. We have to create not for retrieval purpose. There is some reason in RDBMS we create foreign keys relation between two tables, but here two are different files. So already data is presented, right? We are not going to insert one row. Yes or no? In big data we cannot insert one row. This is big data, not small data. So data available in huge volumes of data. So that's why we don't have any foreign key keyword in Hive. Foreign key, primary key, those kind of rules are not available in Hive. Okay. Let's see. I want to retrieve data from employee table, EMP table, EMP table, and department table. So we have two tables. I want to employee name and department name, location. I want to display department name, employee name, department name, location. So if you want to display these three, first one is presented in employee table, right? Second two presented in department table. So here we write query in this way: select e name, comma, d name, comma, d location from emp, comma, dept, where dno equal to dno. If I write in this way, what is this dno? What is this dno? Is it from dept or emp? Is it from dept or dno emp? No, it will confuse. So that's why here it will give ambiguity. So for that one we take reference variables, alias names. For tables, we give alias names. Then we can use here e dot dno, d dot dno. This is called alias name. In RDBMS or Hive we call this is alias name. By using alias name we are clearly saying this dno, take this dno from emp table, take this dno from emp table. So for emp table 100 records are there. 100 records. Let's do some analysis. how internally joins are happen. So EMP we have 100 records and DEPT we have 10 records. DEPT we have 10 records. DEPT we have 10 records. Each row of this DNO, each row of this DNO compare with this table 10 records. So here we have 100 records, right? First it will take first record DNO and compares in first record DNO. Matching or not. If it is matched, whatever the columns list we specify, it will return. And again it will compare second record, third record, fourth record. So first record compare with all 10 records. Again second record it will take and compare with the 10 records. Again third record it will take, compare with the 10 records. Again it will take like this 100 into 10. No, comparison happen. 100 into 10 equal to 1000 comparisons happen. What if EMP contain 1 lakh records, 1 lakh records and DEPT contain 100 records? 1 lakh into 100, right? 1 lakh into 100. So total 1 core. So 1 core comparisons, right? 1 core comparisons. So if number of records are increased, comparisons are more. Comparisons are more. So main drawback of joins is, joins main problem is number of comparisons. Number of comparisons. Number of comparisons. So because every comparison will take some time, right? So that's why it will take time to return data. If data size is small, we get response is very faster. If data size is huge, response time is slow. First, in RDBMS, we have a solution to avoid these joins. To avoid these joins, we have partition concept. Partitions. Everything Hive is taken from RDBMS only. Partitions, bucketing, indexing, all these concepts are from RDBMS only. Yep. Sequence purpose is different. Here we don't have. So we can create a partitions, indexing. So if possible, learn this indexing, how to apply indexing, because in real application development we use indexing, bucketing, and we are going to use partitioning, indexing, bucketing, and views also. Okay. So for implementing we are using, right, this is common column in both the tables and we are implementing in this way. Let's combine in a single column because otherwise. So let's take this one and execute query. So if you observe here, it is saying number of reducer tasks set 0 because we are not applying any calculations. We are just reading data. In that case, it requires only mapper. Whenever you are using calculation or any compare calculation part, it will uses reducer. So total, see, it's successful, but output is 0. Why output is 0? We did not load records into the tables, right? We did not load files, so there is no data in both the tables. DEPT table, did we load DEPT table data? No. Let's see. Select star from DEPT. There is no records, that's why not loaded. Let's load data local in path and batch 5 slash DEPT into table DEPT. Then execute select query. So we got output is match records. Employee name, this one, department, location. Employee name, department and location. We got all the records. So internally it is taken 31 seconds. So to improve performance of joins, we use subqueries, partitioning concept, indexing concept, bucketing concept. No, we used only query to retrieve employee name, department name, and department location. That's why it displayed all these values. Next, coming to left outer join and right outer join. Left outer join. So we have EMP table and we have DEPT table. DEPT table. So EMP table contain 101 employee name and some department number. So let's take 3 columns instead of taking multiple columns. Let's take 3 columns, 12 and 103, and we have CC and 1013 and 104 DD and 14. So department table has 11 dev, 12 testing, 13 HR, 15 accounting. So this is the data. If you apply left outer join, left outer join, left outer join. So we are using table EMP left outer DEPT. So common column we used DNO on DNO on common column DNO. Okay. Next, if you apply this one, first all left side matched values, left side table matched values. So all left side matched values means 11 is matched here, right? So we get output like this: 101 AA 11 comma dev, 11 comma dev. Next one, 102 BB 12 testing. Next one, 103 CC 13. Next one, HR 13 comma HR. Next, 104. So this is matched, right? So we got all matched. Okay. Next one, non-matched records. Non-matched records of left side. So it means 104 is non-matched, right? 104 comma DD comma 14. And for non-matched records of right side table, it display null. Okay, first it displays all matched records of left side one, non-matched records with values of left side and null values from right side. Department number, common column. So this is left outer on these two tables. So if you apply left outer on this table, first match records of both. Match records, it will first compare this one, left side with right side. So matched of left side with right side. Next, non-matched of left side, but values of right side, no right side matched values. That's why we got nulls. So first remember right side non-matched. For this left outer, right side left is matched. Left side all matched records with right side table. Next one, left side non-matched, but right side no values, right? That's why those columns we get nulls. If you use right outer, right outer, same thing. All matched records of right side, right side, right side table. So it means all these are available in both the tables, right? So we get all matched, same. Next, non-matched records of right side. So right side non-matched is only one, that is 15th department. So null, null, comma, null, comma, null, comma, 15, comma, accounting. In this way we get output. So if you use full outer, first all matched, all non-matched of left side, all non-matched of right side. Combination of both is called full outer. Order may be different, but we get the output is in this way. So let's practically implement. So we have a commands, operators, left outer and right outer operators. Left outer join. So this is we taken alias names. Select employee number, employee name, salary, gender, department name, department location from EMPE, left outer, DEPTD, on table, on common column, uncommon column. So our case we require not clear. So then select ename, dname, dname, dlocation, from emp a comma dept d dept d. No, syntax is different here. The empe left outer join dept d on e dot dno equal to d dot dno. So we got right. So there is no extra table, there is no extra column in right side. That's why we got all match records. There is no additional like our example. So if you use right outer, we use same way. So here we use just right outer. Some examples like for each city, total salary is required. City wise we want to find total salary. City is presented in department table, right? City is presented in department table. Then city wise means we use inner join, inner join, join dept on emp dno dept. You can use directly equal to operator or you can use join dept d. Both the syntaxes will work.